So applications again, but this time we're compounding it n times. Now, sometimes it's in a year, sometimes it's monthly. Most of the time it is compounded n times in a year. So when we're doing something like this, one thing we have to look at, the formula is slightly different. Now, the reason is that it's different is because we have a certain percentage rate, and usually it's an annual percentage rate. So 7.5% is considered the annual percentage rate. So they get 7.5% approximately for the whole year. But if we want to compound at different times, so when I say compound, I mean add the interest on. They're not going to give you the full 7.5% if you compound it monthly or weekly. Okay, so they're going to divide your rate by how many times you're going to compound it that year. So if you're going to compound it monthly, so 12 times a year, they're going to take that rate and split it into 12 pieces. And when they do that, they'll raise it to the 12th power, or to the 12 times the year's power, so that we don't have so we still get that compounding. It's still a bit of a goodness, I guess. So the next thing that we do is we just want to look and see if we can write the formula. So remember, they're going to give you an interest rate, and that interest rate will be like for a year. Then they're going to split it up and say, okay, annual is normal. That's the normal one that we've been dealing with. But then semi-annually, they're going to break it up into two pieces. So that's how we're going to use this formula. So to tell the difference between this formula and the formula that we did yesterday, they're going to give you an interest rate, and they're going to break up the interest rate into pieces. So if they give you a yearly or an annual interest rate, they're going to break it up into pieces. So however many pieces we have. So these words, this vocabulary that you have to know, when T is years, you have to know how many times they're breaking up that percentage rate. So I'll write the formula for the first couple, and we'll see how you do for the rest. So for annual, N is 1 because it's just compounded once a year. So it's literally the same formula that we've been dealing with. So A of T. So if I'm using this Nick, so we're using Nick up here, sorry. He has an interest rate of 0.075, and he's dividing it up annually, so that's 1. Sorry. So what we have to do here is time is still T, it's still years, but we're going to multiply it by 1. So this number and this number make no difference in this problem. But once you get to semi-annually, that means twice a year, that number is going to change to a 2. So we just want you to take a second. Okay, divide that by 2, so it's twice a year, but then we have to compound it twice, so we have to multiply it twice. So you do get a little extra for compounding it more often, but not as much as you think. So take a few minutes and try to fill out the rest of this, and I'll come back with the answers. All right, so here it is. Now you can figure out what this number is if you want, but at this point I want you to see what the formula looks like when you plug it in. So you could 1 plus 0.075 divided by 2 is a number. And then, so this 4 goes here and the 4 goes there, the 12s. Okay, so it's dividing it up, that interest rate that we have, the annual interest rate, it's dividing it up into 52 pieces if it's weekly, but it's compounding it 52 times. So it's just the way the formula works. Okay, so 365 for days, and we'll take it from there. Okay, to use this now, what you have to notice, and this is, you have to really pay attention that it's different than yesterday's, is that they're going to give you like an annual interest rate, but then it's going to compound it differently than annually. So comparing those two, you can tell which formula you're going to use. So the formula we're going to use here, since they give you annual interest rate and you're going to compound it monthly, is the one obviously we're doing today. So we're going to take that 8,700 going to add the 3% interest, divide it by the months, and compound it monthly. So, you know, either way, it doesn't matter. If you want to, you can write this as a decimal. Sometimes it's easier to put in your calculator if it's just a decimal to begin with. So there's two ways you're going to do it. You're going to look at it. You're either going to be given the years and you have to plug in the years, or you're going to have to figure out how long it took. So this is the A2 version. This is the A1 version. So this will happen, but you know, it may be a bit more complicated formula than this. So we want to figure out how much she's going to have. So we're going to figure out M of T, or M of 18. So you plug in the 8,700 and literally just plug it in and figure out the answer. There's a few things you do want to make sure you're looking for is, so that's to the nearest cent. Okay, things that you want to look for, make sure, you know, they didn't say to the nearest hundred, like the denominations that they give their money and things like that. Okay, so that's simply just a plug and chug. Now we have ours, so we have to remember whenever we are solving for an exponent, so we're solving for the year here, so our formula is this, 8,700 to 12t. Okay, but now we have to plug in the right thing. So you're either going to plug in t or we're going to plug in M of t. So they're asking you, what year has the investment doubled? Well, it's money, so it's not time, so it's got to be this one. So I have to replace this one with how much it would be if her money doubled. Well, she started with $8,700, so doubled is multiplying it by 2, so 17. So that is the So now this is the formula. So remember, when we're solving for an exponent, we must have logs in the problem. If you don't use logs, you're not mathing correctly. So now we simply solve it. So remember how to solve these. You can't multiply it in, you got to divide. So we get log of 2, as we just figured that out, to the 12t, and just continue. So take it, well, I guess I could keep going for you. So when we log both sides, sorry, I put the log on that part already, that 12t comes out on front, so we get log of 2 equals 12t log of 1.0025, and then we're simply going to divide away anything that isn't the t. So we're going to get rid of this and this. So you can do it one at a time, or you can do it all together. But remember, if you do it all together, to put parentheses around it in your calculator. So doing all that, these cancel out, and we're just left with t. And t is 23.133 years. So it'll take approximately 23 years. Okay, have a great day.